I welcome you all in NPTEL online certification course on mechatronics. Today we are going to see microcontroller programming examples. In the last two classes, we have discussed about microprocessor and the microcontroller, their features, okay, and how do we connect them to the peripherals. All those things we have seen. In this class, I would like to take two examples on the programming of the microcontroller. Okay. So, the first example is on the security system and the second example is on the snake robot. Okay. And first example we will try to do with the help of PIC microcontroller, and the second example we will try to do with the help of Arduino microcontroller. So, let us take the first example, the security lock system. This case I have discussed while taking up the lecture on the logic circuits actually. Okay. So, I am in the few slides I will be repeating the same, that is I will be stating the problem statement. So, define the problem in words. So, first stage for that is that. So, what the problem we are actually trying to solve is that we want to solve the alarm system to create a high signal sounding the alarm for certain combinations of house sensor. Okay. So, it is a house security lock system, and I have taken this example from the Elciator and his 10 mechatronics book. So, we want the user to be able to select one of the three operating states actually. Okay. So, the first state is an active state when the alarm will where the alarm will sound if the windows or doors are disturbed. Okay. And this state is useful when the occupants are sleeping. The second user state could be an active state where the alarm will sound if the windows or doors are disturbed or if there is motion in the house. Okay. And this state is useful when the occupants are away. And the third stage is a disabled state where the alarm will sound, where the alarm will not sound, and this state is useful during the normal household activity. So, the Boolean variables could be say I define A, state of the door and window sensors, B, state of the motion detector, and C, output used to sound the alarm. Okay. And say CD be the 2-bit code set by the user to select the operating state defined by say 01 is the operating state 1, and 10 is the operating state 2, and 00 is the operating state 3. Okay. So, in the first stage only door and windows are disturbed, and in the second stage door, windows are disturbed as well as the motion is detected, and in the third space nothing is happening, normal state. Okay. So, the door and window sensors are assumed to be normally open switches that are closed when the doors and windows are closed. Okay. And they are wired in series and connected to say 5 volt through a pull up resistor. Therefore, if either switch is open, then signal A will be high. Both the doors and windows must be closed for signal A to be low, and this is called wire AND configuration because it is a hardware solution providing the functionality of an AND gate. So, here we can see this is my pin layout for PIC 16F84, and here as you can see that we have the windows push button switch, this one, door push button switch, this one, okay, and they are normally open. Here we have the motion detector, okay, and for selecting of the operating state, basically we have a SPDT, that is a single pole double throw switch, which is being used over here, okay, and here the buzzer is connected through say RA0. We have a crystal connected over here. Okay. So, these are the input ports, basically B0 to B7, the 8 ports over here, and RA0 to RA4, these are the 5 ports. I have discussed a lot about these things in my previous lecture. So, the motion detector produces a high on line B when it detects the motion, as I said, this one, okay, and the single pole double throw switch are used to set the 2-bit code, that is CD, which I talked about. In the figure, the switches are both in the normally closed position, therefore, code CD is 00. The alarm buzzer sounds when signal Y goes high, forward biasing the transistor, okay, and when Y is high, 1K base resistor limits the output current to approximately say 5 milliamps, which is well within the output current specification of port A. So, if we look at the PIC basic program for this case, okay, these are the actually comment statement, say the file comment statement over here. So, first we define the variable for input output pin. So, you can say that door or windows, basically say port 0, motion, that is the variable port 1, say here, the C variable port B2, D is port B3, and alarm is say A0. Okay. This is how we are connecting this one, okay. So, this is port B0 and this is signal A, and likewise we have other signals, and here detected con1 to indicate that motion is detected, and here these are as I said the comment statements basically. So, our programming could be like this, okay. As I defined the C and D, that is the condition states. So, if C is 0 and D is 1, then naturally that is the operating state 1, occupants are sleeping, and if door or windows are open, then it is alarm high, else it is the low alarm, okay. And so, we have the end if statement to close the bracket, or else we have the second condition, that is the second operating state, that is if C is 1 and D is 0, that is the operating state 2, that is occupants are away. Then here if door or windows are open or the motion is detected, okay, then we need to have the high alarm, otherwise we need to have the low alarm, okay, and in case of else we have a low alarm, okay, that is the operating state 3. So, this way actually continue to poll the inputs, and this way this program executes. Fine. This is again I am showing the schematic for this one, the PIC microcontroller, connected with all the devices such as say we have the input devices here, okay, that is switches, motion detector, and for selection of the operating mode, and we have the output from over here. Next, let us take the example of generation of a snake gate. Okay. So, the snakes usually have the different gates, or snakes follow the different gates, or they may be using a combination of these gates. Okay. So, say these are serpentine or lateral undulation, concertina, side winding, rectilinear progression. Okay. So, most snakes are capable to execute all or several of these forms of locomotion and generally switch as per requirement. In some situation, it may even use the combination of more than one gate. So, let us look at the first one, that is the serpentine gate, and here as you can see, this is a S shape movement, also known as the lateral undulation, and is used by most snakes on land and water. Okay. On land, snake usually find resistance point in the surface such as rocks, branches or dents, and uses its scale to push on the points all at once, thrusting the snake to move the forward, okay, as you can see over here. Then there is another gate called side winding. Okay. So, in the case of side winding, in environment with few resistance points, snakes may use a variation of the serpentine motion to get around. Okay. Contracting their muscles and fingering their bodies, side winders create a S shape that only has 2 points of contact with the ground. Okay. And when they push off, they move laterally. Okay. So, as you can see over here, okay, and much of the side winding snake's body is off the ground while it is moving. Next gate is the caterpillar or the rectilinear gate. Okay. So, this is a much slower method of movement in caterpillar or rectilinear locomotion, and I am going to talk about this gate, the example of this gate I am going to take, and this technique also contracts the body into the curves, but these waves are much smaller and curve up and down rather than side to side. Okay. And in this gate, the top of each curves are lifted above the ground as the ventral scales on the bottom push against the ground, creating a ripple effect. The last gate which I am going to talk about is concertina, and this concertina gate, the snake extends its head and the front of its body along the vertical surface and finds a place to grip with its ventral scales. Okay. To get a good hold, it bunches up the middle of its body into the tight curves, okay, as you can see over here, okay, that grips the surface while it pulls its back, okay, and up. It then springs forward again to find a new place to grip with its scale. So, okay. So, this is how the concertina gate works. So, we made a snake bot, okay, using economy standard, say 4.5 kg centimeter servo motors and with plastic gears, and we used U-shaped brackets to connect these motors. And for the controller, we used Arduino Uno, okay, and this is a microcontroller board based on Atmega 328P. Okay. So, here is the pin out connections here basically. So, you can see that here you have A0 to A5, okay. So, we have analog pins, ports are over here, okay, okay, and here as I said Atmega microcontroller has been used over here. Okay. So, it has 14 digital input output pins, out of which 6 can be used as PWM output, 6 analog input, okay, a 16 megahertz quartz crystal, a USB connection, a power jack, an ICSP header and a reset button, okay. And with the help of Arduino, positions of servo motor shafts are controlled, okay, and a code is written for the required gate and is initially verified for any errors, and in the absence of error it is uploaded into the Arduino board and the motion of snake robot is controlled through it. So, this is how the code for rectilinear gate is written, okay. So, we have include command to include library required to control the servo motor, define say omega, define delta, some angle, and then servo S1, this defines first servo motor which sweeps in the vertical plane, and these are put in command. So, these are not used in the this particular gate. So, we have servo S3, S5, S7, S9 over here, and position of the servo shaft is put theta 1, theta 2, theta 3 to theta 9, a float T is defined over here, okay, and then the program starts. So, S1 attach 3, attach 5, attach 7, 9 and 11. So, we are assigning 3, 5, 1, 3, 5, 7 and 9, connect first servo motor to pin output number 3. Similarly, for third to pin output number 5, 5 to output pin number 7 and so on. Okay. So, this is how servos are connected to the pins of that, and then serial we begin, then we give a delay over here, okay, and then the T is defined here, runs repeatedly, the main code runs, there is a further a delay, and then theta 1 is defined like this. And then we have S1, theta 3, S3 and theta 5, S5, theta 7, S7, okay, and theta 9 and S9. So, this way we calculate the angle and then we give that command to the motor to rotate by that many degrees, okay. And so, this is the output motion which you can see which has been obtained over here, and this is for the rectilinear motion which we have got, and this is the Arduino Uno board, okay, and we have used a power supply for this, and of course, as I said the motors are connected to the Arduino board, and by changing the program, likewise we can get the other different gates which I have talked to you, either serpentine or side winding or concertina, okay. So, all those gates can also be achieved, okay. So, this way with this if you want to read you can read these references. The first example I have taken from this book, and yes, and the gates I have taken description of the gates I have taken from howstuffworks.com, that you can look at, okay. And this the snake gate problem which I discussed, it was worked by one of the two of the interns in robotics and control lab IIT Roorkee. Thank you.